Here the results in which the software implementation, description of the block diagram parameter, which parameters which we used in our programming. CD construct transfer function model. What is the CD construct transfer function model? Here it is the small description about this icon of this LabView software. Create a transfer function representation of the system using the sampling time, denominator and delay. This VI also provide a transfer function model which specify the data. Here you see that the transfer function, the input is the denominator, delay, error, sampling time, and the output is the transfer function and the error out, and you use the output and input point according to your record. The second point is the CD draw transfer function equation. Here you see that the symbol of this icon is CD transfer function used for the display the transfer function equation of the model. Third is the CD root locus. Plot the events, which is the name of the scientists which invent the root locus technique. Plot or trajectory of the closed loop pose of a single input single output seesaw system as the feedback gain varies from 0 to infinity. You can display this data in a root locus graph or the indicator. Here you see that in this icon various input and the output point. You use the input and output according to your requirement. And the second is the CD parametric time response. In this icon you can calculate the parametric information such as rise time, peak time, setting time and the overshoot. CD get data from model.vi, obtains the data that describe the dynamics of the given system model.
Right click.
In this lab,
Go to
the simple in this slide we show the
Control
programming in the
model
LabView.
And select the CD construct transfer function. Seesaw single output single input. Here you can give the input like the create control denominator numerator to make the transfer function. Again go to control and simulation, control design, model construction, CD draw transfer function equation. Here the output of this CD construct transfer function connected to the input of the transfer function model. Right click, create indicator for output to show the equation. Again go to control and simulation, control design, and then go to model information and draw the time response and select the CD step response. Here type change transfer function. Output create indicator CD step response graph. Here the transfer function connecting to the input of this. Again go to control and simulation, control design, dynamic characteristics and select the CD root locus. Here you can also change the type transfer function connecting to the show to this terminal. Here the output is the root locus graph. Create indicator for the output. Again go to control and simulation, control design, model information and CD get data from model. Here you can also change the type transfer function. Transfer function is connected to the transfer function, and then go to mathematics, polynomial and select the partial fraction expansion. Here the output of this connected to the numerator of input and this denominator is connected to the input of this. Here create indicator polynomial, same as like poles, and the residue. Again, go to control and simulation, control design, time response, CD parametric time response data. Type change, internal, go to transfer function. Also short the terminal and select the time response parametric data indicator. Here your block diagram is complete.
The values of the transfer function 2, 1, 0 and 2 and 2, 1, 4. Here you run the VI. Here you see the step response graph. Here the transfer function when you give the equations, create an indicator. Then you see the transfer function equation. Here the root locus graph. Here is the 0 and cross is the pause. You can show like that. Double click on this icon, right click and show the properties line width, open loop all zeros. Here you see that the dark line show the pause like zeros. Here you see the visible the zero sign here. The settling time, overshoot, peak time, here is the second order response parametric data are here. In this slide you see that the previously we performed the system. You see in the screenshot you can see that the transfer function, step response graph, root locus and the root locus graph. Here the output is in this figure. You can see that the transfer function, step response graph, you see that the transient response and the stability of the system, and the root locus show the graph shows the poles and zeros. Here the system is the stable. The lab task is check the stability of the system using the root locus. On the LabView software you can draw the circuit in this LabView software. Any question?